Right. So again, this is a multiplying conjugates because the only thing that's different between them is the sign, right? Plus goes to minus. So we know that we don't really need to do all the FOIL. We could just do the F, the first terms, minus the last terms. So this will be the square root of 5 squared minus the square root of 2 squared, which is 5 minus 2, which is 3. If you did the whole FOIL, you should have seen the middle terms cancel each other out. So again, whenever you multiply conjugates involving radicals, it'll cancel the radicals. And that is a strategy that we'll use on the next slide. Okay, so now, example 6. Now we're dividing a binomial radical expression by a binomial radical expression. And truthfully, you know, what kind of number is the denominator? Is it rational or irrational? Because of an unresolved square root, it's irrational. And what did we have to do in last night's homework? We had an irrational denominator. And that's the directions on a problem like this. Rationalize the denominator. It doesn't even say divide. It just says rationalize the denominator. We don't want an irrational denominator. An irrational denominator. Okay, but in this case, if I multiplied by 1 minus the square root of 5 divided by 1 minus the square root of 5, which is what we did last night. We just said whatever's the denominator, do it by itself. We wouldn't cancel all the radicals. I mean, we would get 1 minus the square root of 5 minus the square root of 5, that's minus 2 times the square root of 5, then plus 5. But we would still have radicals. What do I need to multiply by to cancel the radicals? Plus the conjugate, right? That's why we learned about multiplying conjugates. If we want to cancel a radical in the denominator of a binomial radical expression, multiply by its conjugate. That will do it. Okay. So now, in the numerator, it's a FOIL, right? You just have to FOIL them all. In the denominator, this is multiplying conjugates, which we know is not really a full FOIL. It's just the first terms minus the last terms. So this will be 1 minus 5 in the denominator, right? 1 times 1 minus the square root of 5 times the square root of 5. In the numerator, we need to multiply all 4 terms. That'll be 3 plus 3 root 5 plus root 5, and then the square root of 5 times the square root of 5 is 5. Okay, now we have some simplifying we can do. In the numerator, 3 plus 5 is 8. And how many square roots of 5 do we have in the numerator? 3 root 5 plus root 5 is 4 root 5. And 1 minus 5 in the denominator is negative 4. Okay, well, we wouldn't stop there because there's some obvious canceling that we could do here. Right? It looks like 4 will divide evenly into 8, and 4 will divide evenly into 4. And if you're confused about the minus there, it might help to break it into 2 fractions, right? Break it up like this. 8 over negative 4 plus 4 root 5 over negative 4. And now do the canceling. 8 over negative 4 is negative 2. And 4 over negative 4 is minus 1, right? So that's minus the square root of 5.